Hello students, welcome to my YouTube channel Chemphilia, and today I'm going to start the JEE main PYQ series, and I'm starting from the first chapter of class 11, that is some basic concepts of chemistry. And in the year of 2002 there were three questions asked from this chapter, and now I'm going to discuss those three questions one by one. So the first question is asking number of atoms in 558.5 gram of Fe, whose atomic weight is 55.85 gram per mole, and four options are given. Is it twice than that in 60 gram of carbon, or is it 6.023 into 10 to the power 22? Is it half that in 8 gram of helium, or is it 558.5 multiplied by Avogadro number? So let us see. Now, first of all, let us calculate the number of moles. Now, number of moles is expressed by small n. Now, number of moles for Fe, number of moles for Fe is, it is mass divided by atomic weight. Now, what is the mass? It's 558.5 gram, right? And the atomic weight is 55.85. So it means the number of moles is 10. Clear? Now, if it is 10, that means the number of moles is 10. So is it twice than that in 60 gram of carbon? So let us see. First option A. What is the number of moles in 60 gram of carbon? It's mass by atomic weight again. So what is the mass of carbon here? It's 60. And what is the atomic weight? 12. That is 5. And it's indeed, if you double if you multiply this number of moles by 2, it becomes 10. So it's actually option A, that is the answer of this question. But still, if we look at the other options, option B, 6.023 into 10 to the power 22, that means number of moles in this case is 6.023 into 10 to the power 22 divided by Avogadro number, that is 6.023 into 10 to the power 23, that is 0.1. Clear? Now, if we look at option C, half that in 8 gram of helium. So if we calculate the number of moles of helium, its mass by atomic weight, again mass is 8 gram and atomic weight of helium is 4, that is 2. And no, 10 is not the half of 2, obviously. And option D, it's a huge number, so it cannot be the answer of this question. So the answer is option A. So option A is the answer to this question. So I think you have understood the answer of this question. Now let us move on to the second question. The second question is asking, with increase in temperature, which of these changes? So four options are given: molarity, weight fraction of solute, and mole fraction. Now let us see. First of all, molality, molality, it actually depends on mass. It actually depends on mass, and you know mass is temperature independent. So molality. The second option is weight fraction. Weight fraction of what? Weight fraction of solute. Now this is another parameter, weight fraction of solute, which depends on the mass of the solute. The mass of the solute, and you know that mass is independent of temperature. Then if you look at option C, option C is molarity. Option C is molarity. Now molarity means number of moles by volume. Now you know that volume so we know volume is directly proportional to temperature, and molarity, which is expressed by capital M, is inversely proportional to volume. It means molarity is also inversely proportional to temperature, which means molarity depends on temperature. Molarity depends on temperature. So molarity changes with temperature, and option C will be the answer to this question. And if we look at option D, mole fraction. Now remember, mole fraction is another parameter, just like molality or weight fraction of solute. Mole fraction also depend on mass. They depend on mass, which is which is independent of temperature, independent of temperature. Okay, so I hope the options are clear, because three options are here which are independent of temperature. That means with increase or decrease of temperature they are not going to change, only molarity can change. Okay, so I hope this question is clear to you. So option C is the answer to this question. Okay, now let us move on to the next question. And the next question is, in a compound, carbon, hydrogen and nitrogen are present in the ratio of 9:1 is to 3.5 by weight. So basically it's the ratio of mass. Molecular mass of the compound is 108. Molecular formula will be what? So this is the question. This is a simple question from the concept of empirical formula and molecular formula. So let's see how it can be solved. First of all, let us find out the empirical formula. Now empirical formula means the ratio of number of atoms, the ratio of number of atoms of the elements. And how number of atoms are calculated? It's very easy. Mass by atomic weight, mass by atomic weight. So what is the ratio of mass of carbon? It's 9, by its atomic weight is 12. S2, hydrogen's mass is 1, its atomic weight is 1. S2, nitrogen's mass is 3.5 and its atomic weight is 14. So it's basically 3 by 4 is to 1 is to 1 by 4, or we can say 3 is to 4 is to 1. 3 is to 4 is to 1, which means the empirical formula is C3H4N. This is the empirical formula. So if empirical formula is C3H4N, it means empirical formula mass is equal to what? Is equal to 12 into 3, because carbons are 3 carbons are there. Hydrogen is 4 and nitrogen is 14 into 1. So it means 12 3 is a 36 plus 4 plus 14, that is 54 is the empirical formula mass of this compound. Now since empirical formula is C3H4N, so let the molecular formula, remember molecular formula is written in short as MF. So molecular formula is what? C3H4N whole N. So let us consider this is the molecular formula, right? Now what is the molecular weight? The molecular weight is given in the question. So the molecular weight of the compound, is equal to what? Is equal to 108. So N is basically molecular weight divided by empirical formula weight. Molecular weight divided by empirical formula weight. Clear? So what is the molecular weight of this compound? 108, and the empirical formula weight is 54. That is, the value of N is equal to 2. So the molecular formula we can write in short MF. MF means molecular formula. It's C3H4N whole 2, that is C6H8N2. So the answer is C6H8N2. C6H8N2, that is option C, I think. Just a minute, let me check the options. C6H8N2, C6H8N2, yes, it's option C. It's option C. That is the answer to this question. Just a minute. It's C6H8N2. So option C is the answer to this question. Option C is the answer to this question. So I hope you have understood the answers of these three questions, and just don't forget to mention how much you have liked the content. And if you like the content, then please like it, share it, and subscribe my YouTube channel. Thank you.